Okay, we have already looked at knowing how many roots, how many zeros we should have. We even looked at figuring out how many of each type we should have. Well, now let's get into the nitty-gritty of finding some of those roots without the calculator, or how to narrow down our choices even with a calculator. So let's take this quadratic function, which is a polynomial of degree 2. That would mean that we have 2 zeros. Now what we're going to do is we're just going to list out all the possible pairs of factors. So thinking back on when you were factoring, if we were factoring kind of old school, let's guess and check, for lack of a better term. What would be all my possible factors? So, possible factors. So to get 3x squared, I'd have to have 3x and x, right? So possible factors. I could have 3x and x. And to get to a -6 at the end, I would need, well, let's think of some of the options we would have there. Well, one option would be this is a +1 and this is a -6. Another option could be this would be a -1 and this would be a +6. Okay, another option, I could have the +6 here and -1 here. I could have 3x minus 6 and x plus 1. But what else multiplies to be -6? Well, I could have a 2 and a 3, right? So keeping these as 3x and x, I could have a +2 and a -3. Or I could have a -2 and a +3. Or they could be switched. So I could have a 3x plus 3 and an x minus 2. Or the other possible factor could be 3x minus 3 and an x plus 2. Now, for each of these options, we have possible roots. That would mean if we took each factor and set it equal to 0, what would be my possible roots here? So this one would give me a -1/3, and this would be a +6. This would be a +1/3 and a -6. This would be, let's see, -6 and then divide by 3. This would be a -2 and a +1. This would be a +2 and a -1. So notice some of these possibilities, we're getting the same number, just positive and negative versions. That'd be -2/3 and a +3, or a +2/3 and a -3. Or, let's see, subtract 3, divide by 3. That would be a -1 and a +2, or a +1 and a -2. Thinking about all these possible roots, notice that the possibilities, so this would be all my possible roots. I want to list them all out. So we had positive or -1/3. I'm going to start with those fractions. I have positive and -2/3. Then let's think about the integers. Positive and -1, positive and -2, positive and -3, and positive and -6. Now I want to look back at my equation for a second. 3x squared plus 17x minus 6. Let's look at this constant term. The constant term is the one that's not changing, it's not varying at all, doesn't have a variable. The constant term is -6. what are the factors of 6? Or what would multiply to give me a negative 6? Well, I could have a positive or negative 1, positive or negative 2, positive or negative 3, and a positive or negative 6. Now let's look at the leading coefficient. The leading coefficient is the very first number in the polynomial. The leading coefficient is 3. What are the factors of 3? Well, positive and negative 1 and positive and negative 3. What I want you to see is what would happen if I took each of these and divided by each of these. So in other words, taking the factors of the constant divided by the factors of the leading coefficient. I'm going to abbreviate that LC. So I have a 1. 1 divided by 1 be 1. 2 divided by 1 be a 2. 3 divided by 1, 3. 6 divided by 1, 6. Now what if I took each of those and then divided it by 3? 1 divided by 3 be 1/3. 2 divided by 3 would be 2/3. 3 divided by 3 is really just a 1. We already had that listed. 6 divided by 3 would actually be a 2, which we already had listed. So notice that by taking all the factors of the constant divided by the factors of the leading coefficient, we get all possible roots. This is actually called the rational root theorem. Now let's take this function, 6x cubed plus 19x squared plus x minus 6. We're going to graph it, and I'll make a quick sketch here of what we see. So I'm going to go ahead and mark 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, 5. Let me grab my calculator. And we're going to look at this in the calculator. So I'm going to go to my y equals. I'm going to type this in. 6x to the third plus 19x squared plus x minus 6. And let's look at the graph. Notice you can see it passing through -3 pretty easy. But then these other two zeros are in between some values. So let's sketch that. It went up through here, then it came back down and it looked like it went here, and then it went back up through here. So it's really obvious that one of the roots is -3, but the other two are going to be fractions. Now we can narrow down our options by using this rational root theorem. And the rational root theorem says that the possible rational just means it could be a fraction, roots can be found by taking the factors of the constant divided by the factors of the leading coefficient. I'm going to leave out the word the. And this is true on any polynomial. So, to find the possible rational roots, which we can abbreviate as PRR, so we don't have to write it all, we're going to take the factors of the constant, which in this case, that's the factors of -6, divided by the factors of the leading coefficient, which is 6. So let's list out all the factors of -6. Well, that'd be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. The denominator, we'd have the same thing. Now all we have to do is divide. So I usually like dividing everything by 1, then everything by 2, and so forth. That's just a personal preference. So I'm going to divide each of these numbers in the top by 1, which that's just going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now I'm going to divide each one by 2. So 1 divided by 2, 2 divided by 2, well, that's just 1. 3 divided by 2, 6 divided by 2, which is just 3, so I don't need to write that again. Now I'm going to divide everything by 3. 1 divided by 3, 2 divided by 3, 3 divided by 3, that's just 1. 6 divided by 3, that's just 2. Now let's divide by 6. And then 2/6, oh, that's 1/3. 3/6, that's 1/2. And 6/6, that's just 1. Now from the list above, we want to eliminate those values that do not appear to be the values indicated on the graph. Which values from the list could be our roots? Well, I know that -3 is 1. Was 1 or 2? No. 6? No. Could 1/2 be 1? Yeah, could -1/2 be 1? Yeah, those are possibles. What about 3/2? That'd be 1.5. Nope. Could 1/3? Yeah. Could 2/3? Yeah, because we were between 0 and 1. What about 1/6? Yeah. So, we know -3 is 1. And if I did my synthetic division with -3, how would I know for sure that it is a root? 6 times -3 is -18, add down. 1 times -3 is -3, add down. I get a -2. -2 times -3 is a 6. Notice that my remainder is 0. So -3 is a definite. Which one do we want to check next? Now remember, I could divide into the original or what's left. I think I want to use what's left. So I'm going to use 1/2 and divide into 6, 1, -2. This will be a little bit easier. Now hopefully if it is a factor, I get a remainder of 0. 6 times 1/2 is a 3. 3 plus 1 is 4. 4 times 1/2 is a 2. -2 plus 2 is 0. Yay! So x equals 1/2 is another 0. Notice that I'm left with only 2 terms. That's awesome because I've narrowed down everything until I have an x. So remember, this was an x cubed. So this would be an x squared. This is an x squared. So this is an x. This is really 6x plus 4, which if I set that equal to 0, I get 6x equals negative 4, x equals negative 4 divided by 6, which is negative 2/3. Let's get to the next one. So using the rational root theorem, we want to determine the rational roots for each of the functions below and then use synthetic division to check them. So let's list out our possible rational roots. So this is the constant and this is the leading coefficient. So what are the factors of 10? Well, that's plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And for 6, so let's list out all the possible rational roots. 1 divided by 1, 2 divided by 1, 5 divided by 1, and 10 divided by 1. Now the fractions. 1 divided by 2, 2 divided by 2, 5 divided by 2, 5 divided by 3, 10 divided by 3, then divide by 6, so plus or minus 1 over 6, 2 over 6, whoops, I missed one somewhere. I forgot 1/3 and 2/3. Oh my goodness. How did I do that? I don't know. 2/6 is 1/3. Then we'd have 5/6, and then 10/6 is actually 5/3. Now, how could I narrow this down? Well, I could use the calculator. So let's see if there's any in here that could help us narrow it down. I'm going to look at the graph. Do I see any good ones? Ooh, that's a fraction. I see a good one over here at 2. So it looks like we have something between -1 and -2, between 0 and 1, and then at 2. So I know I've got one at 2. That's awesome, because I can use 2 to shrink this down into something more manageable. 12, 13, 26, -5, -10, and yes, we get a 0. So 2 is definitely a factor, or a 0. Now what I'm left with is a quadratic. If you are good at factoring quadratics, you can go ahead and factor 6x squared plus 13x minus 5. But if you're not, let's take that and start playing. So I'm going to start with, I know I need a fraction over here. That looks like it could be, I'm going to try like 1/2 and then 1/3 and see if either one of those work. Okay, so bring this down. 6 times 1/2 is a 3. This would be 16. Half of 16 is 8. Oh, that one didn't work. Let's try 1/3. 6 times a third is a 2. That gives me 15. Third of 15 is 5. Oh, looky there. We got one. And what's left is a nice linear factor. So that would be 6x equals negative 15. X equals negative 15 divided by 6. They're both divisible by 3, so that's negative 5 halves. So my zeros are 2, 1/3, and negative 5 halves. Let's list out the possible rational roots of the next one. So the constant is a 3, so plus or minus 1, plus or minus 3. And then 18, my goodness, 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9, and 18. So that gives me plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3 halves, plus or minus 1/3, then 3/3 is just a 1, plus or minus 1/6. 3/6 is just a half. 1/9. 3/9 is 1/3. 1/18. And then 3/18 is just 1/6. Let's see if we can narrow this down. Oops, let me clear that out. 18 x to the third plus 15x squared minus 16x plus 3. Oh, do you see over here it bounced? So something over there has a multiplicity of 2. It bounced. That means it's going to go in twice. So that doesn't really look like a half to me. You can even zoom in if you'd like and see if we can see it a little bit better. So half would be like right there. So this is less than a half. Let's try a third. And I didn't have any whole numbers, so that's a bummer. But it's okay. Now, if this is a factor, it's a double 0. So it's a multiplicity of 2, so we can go twice, which would be awesome. So 18, a third of 18 is 6. Add down. A third of 21 is 7. Add down. A third of negative 9 is negative 3. Lo and behold, it is that factor. And since it was a double, I can go again. Now I'm going to show you a nice trick. Instead of rewriting this, I'm just going to divide into what's left. So I'm going to do 1/3 again. A third of 18 is 6. Add down. A third of 27 is 9. And it was that multiplicity of 2, which is awesome. And I'm left with a linear factor, 18x plus 27. So that's 18x equals negative 27. That would be x equals negative 27 divided by 18. That's going to be negative 3 halves. So my zeros are negative 3 halves and x equals 1/3 with a multiplicity of 2. Possible rational roots. The factors of the constant, so factors of 6. over the factors of the leading coefficient, which is 8. Well, that's a lot nicer than the 18. Okay, so I would get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Divide by 2. 1 divided by 2, 2 divided by 2, 3 divided by 2, 6 divided by 2, are you taken care of? Divide by 4, 2 fourths, 3 fourths, 6 fourths is just 3 halves. Now I'm going to divide by 8. 1/8, 2 eighths is a fourth, 3 eighths, 6 eighths is 3 fourths. Now I want to narrow it down, so I'm going to grab my calculator. Y equals 8, whoops, I need to clear it, 8x to the third minus 6x squared minus 17x minus 6. Graph. Oh, there's some negative numbers over there. Ooh, it's a constant, integer, 2. Oh, and these are negatives. Okay, so let's remember that. So we're going to start with the 2. 8, negative 6, negative 17, and negative 6. 8. 8 times 2 is 16. 10 times 2 is 20. Now, I know this is a negative number, and it's between 0 and 1. Doesn't that look like it's about halfway? Let's try it. Let's try negative 1/2. 8 times negative 1/2 is negative 4. Gives me a 6. 6 times negative 1/2 is negative 3. We guessed it right. And I'm left with 8x plus 6, which would give me negative 6. 6 divided by 8, which is, whoops, I didn't mean to put a comma, negative 3 fourths. So my zeros are 2, negative 1/2, and negative 3 fourths.